Okay, this is a short video to replace our class, which we can't have due to the many holidays in the semester. So the topic is on what I call this section view. So before that, let's look at the schedule that we are going to have. So today, the 2nd of January, we're going to look at this topic, sectional view, and after that, I'm going to give you an exercise which you can do it on your own. And next week, week number 13, I will do together with you the assignment number 4, face to face in the class, and after that we will sit for our test number 2, which will cover the topic of isometric drawing uh, plus the what I call this the sectional view what we are doing today. Yeah. All right. So after that, of course, is Chinese New Year, so you can have your holiday after that. All right. So today's topic, we're going to cover three CLO, which is CLO 1, 2, and 3. So is to able to apply the knowledge in technical drawing on engineering equipment, and also to identify the mechanical parts, and also to use the tools which is AutoCAD to draw the drawing that we want. Yeah. All right. So sectional view, basically the main purpose is to document your design of a single part, so that it is in one piece and with all the details inside. And you should be able to show all the multiple parts and how to assemble the equipment together if you have all the details, and to look at the inside, the internal part of the equipment. Yeah. So if you look at this honeydew, if we don't cut it, we will not be able to see what is inside. And to able to see what is inside, we need to cut it and see the details inside, so that we can draw it, and also to give all the dimension in the drawing. So this kind of cutting, when you cut an equipment into half, is what we call the full section. Yeah. So mostly this is what we're going to do for this part of the drawing. So the cutting plane is important that we see where is a cutting plane and the arrow. Yeah? So if we have this piece of equipment, so when we cut it in this using a knife, and the direction that we want to view the cutting is through this way, is this way. So when you do that, so this is the arrow that is important for us. So when we cut, and we will throw away this part, and whatever we can see from this direction. So the direction of the view is important for us, the cutting plane, and wherever the knife go through in the drawing, that is where the hatching is, and all the details about them. All right. So as you can see, when we cut an equipment, so there will be certain part where the knife will go through, and certain part which the knife didn't go through. So, but then it doesn't mean that the place where the knife didn't go through, you don't draw. You need to join the equipment so that it look as a continuous equipment. So even though the knife is here, you cut it in such a way, but then you still need to draw the one which you can see at the back, which the knife didn't pass through. So that's the purpose of the drawing. All right. So in terms of labeling of the drawing, as you can see, most of the time we will use the symbol A and A to mention about one cutting. And if you want to cut the same equipment, the same piece of equipment, you can label it as B and B. So each of these are actually independent of the other. And as you can see from this view from the top, so when we cut the equipment from AA, so this is what we see. So this part we will throw away, and when we look at it from this direction, and we can see the knife pass through here, and here is empty, so there's nothing. And then this part again, the knife passed through. So you see the detail as such. And for cutting on section B and BB, so you will see that what you see, the result of the drawing is such. So this is a part where the knife passed through, and the empty one is actually empty space, you can see the back as such. Okay, so that is what we call the full section view from an equipment. Okay, so there are certain rules that we have to observe in producing the section view. The first is make sure that the edges, the contour that are not visible, they are now visible behind the cutting is shown. So you don't leave your equipment, the drawing, hanging like this. Even though the knife didn't pass through the back here, yeah, when you cut through this plane, yeah, and the knife didn't pass through here, but you need to join the equipment as such. Yeah? So don't leave it hanging as what we seen there. Yeah? So we can still see the line at the back. It's only the front portion that we are throw away, and whatever at the back we can still see. Yeah? So that is the first rule. And the second rule is that you have to omit hidden lines. Yeah? Even though you do your cutting on here, on this plane, this should be a hidden hole at the back, but you shouldn't draw it here. Yeah? So in a simple term is that in section view, there shouldn't be any hidden line. Yeah? We shouldn't have any hidden line in section view. Yeah? That is rule number 2. And rules number 3, you should actually, section view should be always completely bounded by visible line and never by hidden line. What I mean by that is that you cannot have hidden line in the drawing and then you have the hatching on. Everything must be solid visible line, not hidden line like this. So that is what we mean by that. So and then the fourth rule is that whenever you do a hatching, make sure that the direction is always the same. Don't use another direction on the left and another direction on the right. It shouldn't be that way. Yeah? It should be the same direction all over. Okay, and the last rules is that the visible line can never cross the sectional area. Yeah? So you cannot let the hatching pass through a visible line. So this is not possible. Yeah? So things like this is wrong. So you cannot have cutting through a solid line. Yeah? So the best drawing is this one, what you see at the bottom here. So no hidden line, center line is all right, and then no visible line where the hatching passed through. Yeah? And the hatch is all in the same direction. Yeah, all right. And then, so the section line, the best for us in AutoCAD is that we choose ASN131. Yeah, so then you have fulfilled all these requirement. Yeah, so which is 45-degree hatching, and the line thickness is such. It shouldn't be having some having a bigger space and some having very dense. And then it shouldn't be also something like this, which is almost like a dark color, where the lines is too close together. And then this one we have many different width of the line, and then this one the line is too thick, almost similar as the visible line. And then this one where you have the hatching going over the visible line. So this is not good. So if you were to choose ASN131, you should be safe. All right. So in AutoCAD, you will see this hatching symbol in your ribbon at the top. So if you were to click this hatching ribbon, so you will come to this second ribbon, and this ribbon you can see very clearly the ASN131 is here. Yeah, and of course if you want more, you can actually click here, and then you will get more kind of hatching available for different material. From here you can adjust your density, you can adjust your angle, and so forth and so forth. But this you will use once you have the drawing what I call it, being cut through a plane. Yeah? All right. So for other materials, this is for other industry, maybe construction and things like that. So they will have they will have raw and all that. But for us, we are not so much concerned about this. So for us, it's just the regular 45-degree line will do. So we'll go for number 1, which is the AS131 I was talking about. All right. Then, okay, so now we have talked about full section just now, where we cut equipment, a piece of equipment into half, in a straight cut. But then there are certain times we have half section where we only cut half of the equipment rather than cut the whole equipment. So most sometimes because they are similar both sides, symmetrical, so you just cut one side and you review the information that you want. And sometimes because this information is more important compared to the other side, so you only cut one side of the equipment. So at the end of the result of the cutting is such that when you cut it in such a way, then you only have one section which is being hatched, you have the cutting, and the other section which is the normal drawing that we have. So this is what we call half section. But I think mostly since we only have 2 weeks, we're going to do a full section only. Okay. And the other one is what we call offset section. Offset section, normally you go through places where you want more details on that part. So for example, this equipment here, when you want more details about this hole and this section and this part and here, so your cutting will be not a straight line, not a linear line. You will cut through this hole to reveal more information on this part, and then you move up to here to see more details on the other parts, and then you move further up to get the other parts, and then you move down to get more details on this part. So it's not a straight line, it's a cutting as such, but then your drawing at the end is still on a plane surface. You put everything straight and not crooked like what drawn in this line. So that is what we call offset sections, because we want to see details for different parts of the drawing. All right, so this is the example that we have used this question for test and also for your exercise 3.1, where we asked you to draw the orthographic view of this equipment. So you can see it from the front, how do you see it from the top as well as from the side. So the view from that. So we have seen the answer more or less like this, where the top view is such, the front view is such, and then the side view is such. So this is a third angle projection for this without the dimension. You can see the hidden line as well as the center line. Well, when we want to do section view, so let's say I want to cut the equipment through a section view of AA. So we want to cut from the middle of this equipment. So what do we see? So if we were to base on what we discussed just now, so we will see the answer is such. Because the direction of view now is this, and then when we cut, we will take away the front part and we only see whatever left over. So whatever left over is this, and the knife only passed through this section and all the way down. And the one at the back, actually the knife didn't pass through, and you do not need to put the hidden line for that. So there is no need to put the hidden line for the two hole at the back. All right, so that is what we call section view for AA. But then if we were to turn around the equipment and cut it from a different point of view, so if now we want to cut it from here, instead of cut it from here just now, so if I'm doing the cutting for BB here, so what we will see from here is that we are cutting from here in the middle, and the resulted view will be such. So I will see the equipment as such, where the knife only passed through the middle, but not this part, but it's still visible, and I don't see anything at the back. Whatever is hidden, and I do not need to actually review in my drawing. All right, so that are the two examples which you are quite familiar with, which you have seen in the test and also in your exercise. I hope you can understand more through this. And after this, you will just go through the exercise and try to produce the section view that it is quite required. Okay, I think that's all. Thank you.